And I can see you. This is amazing. Okay, good morning, everyone. Well, it's 8 a.m. my time, wherever you are in the world. I hope you're having a great day. I am here to talk about the intersection of PL, which is, of course, something that brings this conference together, as well as HCI, which is my home intellectual territory as an assistant professor at the Harvard John A. Paulson School of Engineering and Applied Sciences. The title of this talk is taken from an article that I've been writing with the two people listed last on this list of kind of contributors and inspiration, Sarah Chasins in UC Berkeley and Joss Sunshine at CMU. So I'll talk a little bit about our visions for what PL and HCI can look like, how they can grow together in the future. But before I get to those promising future directions, I'll talk about a way of thinking about designing systems that I have adapted from Professor Haoqi Zhang at Northwestern. And I'll explain that in the context of an interactive program synthesis by example system that was recently published at WIST with Dr. Tianyi Zhang, Priyan and London, two students working with me at Harvard. Okay. So, yes, design arguments, goals, obstacles, and approaches is where we're going to start. Then the case study is program synthesis. Talk about specifically usability issues with program synthesis, by example, and then some specific characteristics for how we address that. We'll also mention riskiest risks, which is kind of risk limiting actions to reduce our uncertainty about how, if we spend 6 months developing a system that truly will be usable. And then we'll get back to the promising research directions. So these design arguments think of them as mental debugging. I use them when I'm writing papers, when I'm writing grants. I teach them in my undergraduate class. I teach them in my graduate class. So no one's too old to have kind of a structure for thinking about the arguments they're making about the value of the interactive system they're building. And they roughly break down into a need thesis and an approach thesis with evidence to support each. So on the need thesis, it's good to be able to specifically say who, right? What is the person's role, or in what setting is this person needing help? They have a goal that they want to achieve, but there's some obstacles that get in the way. And because we're engineers, sometimes we want to help people achieve new goals, right? We're not only in a situation where we have to focus on existing goals. And so we can argue that people could and would want to achieve a certain goal if we removed some things that are actually obstacles to that new goal. And the evidence that we can often use here is how our existing approaches failing, right? So in the context of even something like language design, say, well, people continue to misuse this particular operator, right? They want, anytime you see user error, right? The user is not necessarily wrong. They are human, and we design for humans. So if they continue to struggle, the design is not good. And then we have our approach thesis, right? So this is essentially a set, one or more characteristics that we hypothesize will help people get around the obstacles to the goal. So evidence could be in the form of evidence that you're to invest in that hypothesis, which will of course require a lot of building to test potentially with higher and higher fidelity prototypes, would be that these characteristics have been borrowed from solutions that succeeded in analogous situations, right? So if you're considering a new language component, like, well, people in CSS were able to use this effectively, right? Or maybe you presented it, you faked having it in the system and you showed it to stakeholders and they were able to respond positively to it. They understood what it was. Or maybe these are choices, not that you borrowed from analogous situations, but rather that are just different from the existing solutions that are failing. Okay, so that design argument is how I mentally debug things. And I'm going to explain this paper in terms of those design arguments. So this paper just recently presented at WIST, that's the User Interface Software and Technology Conference, kind of the technical wing of the HCI community. And it's a collaboration with Jinyu Wang at University of Michigan and led by Dr. Tini Zhang, a postdoc of mine who's on the job market. So the idea here was that examples alone, we need to augment the way in which people are expressing their intent to get interactive program synthesis to do what they want. So more specifically, say, you're sitting here with your synthesizer, and the user is going to give the system one or more examples of an input and output for a program that they have in mind in this particular setup. And the system's going to return, this is the program they have in mind is match strings with A, B, and C. The system is going to return one or more candidates that would return the same outputs for those inputs, right? So it's got a set of programs from those that it's dreamt up and hands them back. If the user does not like any of these candidates, the user can add more examples that hopefully help the computer guess the desired program, right? So, or a sufficiently equivalent program that was in the user's head. But of course, it's difficult to come up with, well, yeah, so let's look at, rather than, let's look at these obstacles to each of these steps, right? It's not easy it's not an easy task for the human to pick examples that help their non-human collaborator in this exercise, right? To guess the right program. And there's also a lot of reasons, because the computer is not another human whose thought process we can imagine with a shared context we can assume, right? So it's like my mental modeling, which I do with other humans to make rational speech acts, right, is going to fail here if he's not, unless I have some information about how the system is working. It's also cognitively effortful for the human to analyze the input space and how that maps to the outputs that they want, and which set of small examples most fully specifies what they want, right? So this input output space analysis for example selection, that's cognitively effortful. Also, a handful of examples, which is all the human really wants to ever get to come up with, can be generalized into a program in many different ways, right? So here I've handed you a couple examples. If you have the same inductive bias as I do, right? Sorry, when I say you, I mean if the computer has the same inductive bias as the human, then we're fine. But the likelihood that those inductive biases are aligned can be low, especially for really complex environments. And so, the less aligned our inductive bias may kind of have to give more and more examples just to clarify, and that really reduces the utility of the system. And finally, whether the user is an experienced program or an inexperienced end user, programs can be difficult to read, right? And they are definitely effortful to mentally apply to current and hypothetical future inputs. So these are usability obstacles of traditional program synthesis by example. And the approach characteristics I'm going to describe to you today in this published work address these three, right? Input output space selection, or space analysis for example selection. The fact that programs are hard to read and effortful to apply to new hypothetical inputs, to double check that this is indeed the program equivalent to the program you had in mind. And that small number of examples, small number you want to give, can be generalized in multiple ways, and there's the ambiguity there, right? So going back to our design argument, we've got a user, we don't put any specifications on them, right? They're just, their goal here is to programmatically filter strings using PBE, but it could be a more general goal, just use PBE system. The obstacles are mental modeling, example composition, generalization, ambiguity, and mental program simulation. Okay, so we implemented and demonstrated this. Excuse me. This is an interface in which I'm going to explain the affordances that address those obstacles. Right. So we're using an off-the-shelf regular expression synthesizer called Rego, which was developed, I believe, by Jinyu and his collaborators, which synthesizes regexes from examples using enumerative search on a program space defined by a domain-specific language for regular expressions. So as you can see in the middle here, these are where the regex candidates are being generated when synthesis is complete. There's a little bar that, you know, kind of, there's a timeout in case synthesis fails. And so while these programs in the middle do not look like regex programs, they're actually a little bit more readable. It's a domain-specific language that is functionally equivalent to, limited in its differences to the classic regex language. On the left, we have a place where the user can provide positive and negative examples for strings that they want to be accepted or rejected by the regex. And on the right, we have something called show me more examples, so I don't have to come up with my own. And there's two variants here. One is show me familiar examples, and one is show me corner cases. And also, given that these are clustered, you can generate more, show more or less examples per cluster. Okay, so the prior state of the art here that's represented in this experimental interface is the just providing examples, and also the regex candidates with this annotation feature. I didn't call it out specifically, but this is actually borrowed from Hila Peleg's work. She put forth an interaction model where you could, as the user, shape future synthesis iteration steps by annotating individual components of synthesized programs with either include this in future synthesis rounds or exclude this. So if you think about primitives or means of combination, that would be part of the search tree. Prior state of the art is represented here with examples and program annotation. And the conceptual additions that we're making here, the approaches of our particular the characteristics of our approach are first semantic augmentation, where I can, as the user, give one example, but that is kind of a skeleton on which I can provide a little bit of extra annotation, right? I can mark as literal that plus sign in this example, and mark as general all the other numbers, right? To say, you know, I don't actually care that this first number is a 9, right? I'm generalizing this to a certain class, and there's a little pop-up button when you mark something as general. It's just like, how general, right? Any character, this character class. That light annotation turns a single example into a much more powerful example. And then the second characteristic of this interface is data augmentation. So the idea being that both you can grab we can pre-compute additional examples, dream up similar and distinct examples from the examples you already gave, and you can see how, say, the selected regex candidate, how it will accept or reject other familiar examples and other corner case examples, so that you don't have to mentally simulate. You don't have to come up with additional examples. You don't have to mentally simulate how the candidate programs would work. Right, so the example generalization ambiguity, that obstacle that we identified, we have our semantic augmentation to work with that. Here's a screenshot of the selection where you can explicitly annotate how far to generalize that example. Okay, and so that's our design hypothesis, right? We can defend the link between this characteristic and the obstacle that we initially observed. In the back end here, Regal, this is a screenshot of the DSL for the DSL for the regular expressions that Regal is using. And so to allow the semantic augmentation to work, all we have to do is when we get, say, a specifier, we can replace something more general with, say, oh, this person marked it as a literal, for example, and that just constrains our search tree. So small modification of the synthesizer for a big effect in terms of the expressiveness of what users can say with very little effort. Right, so the second, well, actually, so data augmentation, that characteristic maps onto both the input-output space analysis and programs being hard to read and apply to new inputs, right? So two obstacles are addressed by this one characteristic of data augmentation. And we, in the back end here, are generating both positive and negative examples by taking the synthesized regex that was selected and creating a DFA, and then enumerating paths to the final DFA to generate, you know, as starting from, depending on whether we're trying to generate familiar examples or corner cases, right? You can either be using a coverage algorithm to select various inputs, or you can be modifying the existing inputs and going through the process of generating these additional positive examples. Likewise, if we're generating negative examples, then we can take the DFA complement and enumerate paths to that failure case to generate additional negative examples. Right. If we take this as a system now, we can experimentally test whether it is going to, you know, whether our hypotheses about the characteristic semantic augmentation and data augmentation truly do help users get around the obstacles that we identified. And we are going to do that by I'm speeding up a little bit here so that we've filled in the approach thesis, mapping these characteristics to obstacles, and the evidence that I'm going to rely on to convince myself and other people that this is valuable is is how stakeholders respond, or how users respond to this approach. So we are going to create that prior state of the art becomes our control interface. And so we're going to do a within subject study where people in a randomized or counterbalanced order are going to experience just the prior art or the prior art plus these additional characteristics to see how that changes their ability to use the interface. So in this evaluation, we got 12 computer science students. And in the experimental condition, this took place, each of these 12 people were in the lab virtually over Zoom for about an hour. We gave them, I believe, one programming task in the control condition, one programming task in the experimental condition. These were Stack Overflow questions that were reasonable regex questions that you might be able to use this interface to solve. And so for the 12 participants, when they were in the experimental condition, they all finished the assigned programming task. And it only took them, on average, 3.3 synthesis iterations. In the control condition, same people, right? Because this is within subjects. So when they only had the prior state of the art, only four participants were able to finish the tasks, and it took them many more iterations, over double. So we asked them at the end to rate their level of agreement from 1 to 7, that's a 7-point Likert scale, on a statement like, I feel confident about the regular expressions synthesized for me, right? And so this is explicitly to do with the mental challenge, the fourth obstacle of knowing what the program that was synthesized for me that I selected, you know, what it's doing on my behalf, how it's going to behave in the future. And we find that the control is pretty even. That's a bimodal or flat, right? In terms of people saying, yes, I'm confident, no, I'm not confident. But as soon as we introduce the experimental interface, when they respond to this, they say, oh, suddenly I'm pretty confident. I know, right? Because you've calculated for me how it will behave on similar and even radically different inputs that I couldn't probably even have easily imagined how, you know, what it's going to do. You calculated that for me. And we second asked them questions 5 questions from the NASA TLX cognitive load survey. So this is this is kind of like a go-to survey that we use to try to assess how difficult it is to use this interface, right? So the first question is, how mentally demanding was using this tool? How hurried or rushed were you during the task? How successful would you rate yourself in accomplishing the task? How hard did you have to work to achieve your level of performance? How insecure, discouraged, irritated, stressed, and annoyed were you, right? So these are clearly things that if you're designing a new system, well, okay, I mean, obviously, I'm sure you do not want to torture the users of what you're building. However, I do understand that sometimes, I mean, programming is hard, right? Like people are I don't think we're gonna live in a future where programming is just effortless every moment, right? But at least we can look at this to look at comparable effort for the same output. So as you can see here in the control, scores are across the board the same or much higher, right? So it's interesting that for performance, you see a lot more weight towards lower scores on the question about how successful would you rate yourself accomplishing the task. So they were objectively successful and they felt objectively successful. And also you see in the frustration, they felt less, they rated their feelings of insecurity, discouragement, irritation, stress, and annoyance much lower. So just to describe how their behavior in an interface, right? So I've given you a lot of high-level statistics. Oh, these folks finished, this is how long it took them, but let's look at how the introduction of additional interface affordances changed how they made use of the interactive program synthesis system. So all participants in the experimental condition used semantic augmentation while accomplishing their task, right? Every single one of them found it to try it at least once. And participants added 3 semantic augmentations over the approximately 3 iterations it took to accomplish the task when they were in that condition, right? So it's actually roughly 1-to-1 ratio of providing semantic augmentation to synthesis round. So they didn't just try it, they used it. So in more than half of the interactions, participants in the control condition manually constructed examples as additional specifications of their intent. And without data augmentation, they were constructing additional examples, right? There was that instinct to do it. And when they had access to the data augmentation in 2 out of the 3 iterations that it took them, they used the data augmentation to help them understand program behavior and recognize anything undesired, as well as roughly half of them directly took examples from this data augmentation panel back and added them as additional specifications of their intent, right? So they no longer had to come up with their own examples. Actually, I realized I don't have data as to whether any people who had access to data augmentation also generated their own examples. But I suspect, given that over half of them made use of the examples given to them, that they probably generated less. And finally, participants annotated, they made use of Gila's prior state of the art. They did annotate 5 sub-expressions in the control condition. But once they had other means of expressing their intent, other than engaging directly with the programs, and these are CS graduate students, right? Or maybe some undergrads. So they're not uncomfortable with programs. They use this feature significantly less when they have alternatives that were directly dealing with examples as opposed to programs. And that's one of the main, I think, the conceptual takeaways here is that people felt more comfortable being augmented in the example space, right? Or being able to augment their examples with additional annotations than having greater power in the space of programs. Because in a certain sense, I mean, examples are their world and the programs are the synthesizer's world. Think about it that way. So we also did a more, what might be a more traditional evaluation of the power of this technique. Traditional in, say, research spaces where user studies are not a standard means of evaluation. And so we grabbed 20 Stack Overflow questions. The authors themselves tried to solve each one of them, timed themselves, recorded how many iterations it took. And so expert users, which are those on our author set were certainly, were able to, on average in 5.4 iterations, get to the answer, as well as in just under 5 minutes. And these are questions that, you know, other programmers had on Stack Overflow. It's unclear whether they got an answer to their question in 5 minutes, but with regex, with this system, which we're calling regular expression generation with augmented examples, they would have been able to do it themselves in 5 minutes. So that summarizes how I, as an HCI professor, helped structure this team of Tini and Jinyu and London. They are on the SE and PL side, and I being on the HCI side. We found these design arguments to be really helpful. Again, going back to the theme of this talk, PL and HCI better together, right? We found these arguments really helpful for making sure that the immense amount of time that was going to be taken to develop new affordances for interacting with the synthesizer. We had to modify the synthesizer. We had to, you know, all these requests that we were making of Jinyu. I think at the time he was still a researcher at MSR, that they were well justified, right? And that we weren't going to have a nasty disappointment at the end, right, of investing 6 months of our lives in building this, you know, new thing, and then finding out that people were no better for it because maybe the clarity of our thought leading up to the design of those affordances wasn't strictly motivated or well motivated by the needs of the user. So speaking of nasty surprises, right, I'll just mention another thing that I, again, adapted from Haoqi Zhang at Northwestern. You know, I don't know if anyone's familiar with Quibi. It was a very short-lived streaming service. And if I were to write the design arguments about that service, it was that the need thesis was not clear. I'd say people want to watch videos while they're on the go. Okay. So videos need to be within a, let's see. So the approach thesis for Quibi was that videos could be no longer than like 6 or 8 minutes. And also because you're on the go, maybe you're moving your phone around. And so you could, they had bought some proprietary technology that was able to switch around the orientation of the video very quickly and seamlessly while you moved your phone and you were watching. Okay. And so their hypothesis, right, which they got $1 gazillion to invest in, was that the ability to seamlessly move your phone and to have high quality content that was 8 minutes or less addressed the needs that users had. And a lot of people pointed out that there are short videos already, right? That maybe they had misidentified the needs, and that the approach of being able to move your video around is not actually addressing a core problem that people have, right? And $1 bazillion later, they folded within 6 months, I think, of being announced. So they could have used riskiest risk or some other kind of risk limiting exploration of the uncertainties, right, in their argument about why they're bringing value to the user to save themselves and themselves a lot of embarrassment and other people a lot of money, right? So the first question, right, is to identify riskiest risks, right? So what belief do you have that if it were false would have the biggest impact on your design? I have a lot of opinions about how I think people in the future should interact with data, but you know, there are opinions, they're beliefs, right, based on prior experience, but they're still beliefs about the future. And you know, I, 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 you know, I there's always the possibility that our beliefs are wrong. And if we continue to not test those beliefs, especially those that would have a ginormous impact on the design, then like you're just going to have to confront that later. So might as well confront it as soon as you identify it and try to continuously identify these, right? And so once you've identified a belief that you have that would, if wrong, would have a big impact, then you can brainstorm what strategy would take, it might take to make the, strategy might take the minimal amount of effort to reduce your uncertainty about whether your belief is accurate, right? So it's more about reducing uncertainty around a belief than necessarily, convincing ourselves that the belief is indeed true or it is indeed false. Regardless of what it is, we want to know which, so that we can update our approach and also our understanding of the need. So this could be as simple as Wizard of Oz, right? Where I ask my friend to sit in a Google Doc and ask them to do something in Google, and I pretend to be an automated agent or program synthesis tool that is editing the document as they go, trying to introduce features that would take months and months to implement, right? But I'm just trying to get a sense of whether would that be confusing the person, right? What do I need to do to make sure that I have a feeling that this would, I have tested out the interaction before investing in the technology. Now, I realize that I'm very grateful to the PL community for growing the amount of technology that's available for someone like me as a designer to make use of, right? So you're growing out and you're trying to solve big problems and you're growing out in many different directions. And so, I think there's value in just figuring out what is possible technically, right? And I think the value of HCI in that conversation is, okay, there's a subset of these things that you've shown are amazingly even possible, right? And the subset of things, address these particular needs. And here's how we can, really match up our understanding of user needs to these things that we now know can be done. So, rather than, have an idea for a system and then 6 months later show it to someone, right? The idea here is that we're constantly iterating both on our understanding of the need and our understanding of what approach is necessary, and until, we're ready to publish. And then also that if we are, specifically, if we have technical ideas that we're very excited about, rather than starting with the need thesis, we can start from the approach thesis and say, look, I've got this brand new idea for how I can, make a better flash fill or, a new programming language. I realize not everyone in PL designs new programming languages, but, for the sake of it, an easy example, right? Like, I have this new language, right? What is it good for, right? And you can start from the technology, but then also refine what your understanding is of what the needs that it addresses, and then potentially even iteratively update what you're offering as part of that new design, right? Thinking about need theses and approach theses does not restrict us to only ever starting with existing or with needs. Okay, so finally, I will talk about these promising directions, research directions in PL and HCI. I would feel it's a bit, would be a bit daunting to expound on what I personally think would be the most exciting things, but thankfully I don't have to. These were composed with Sarah Chasins and Josh Sunshine. So I've been given permission to speak for all three of us in this regard. So just to the PL folks, right, who I expected the majority of, say, the audience at this conference, we encourage you, even if it's not your forte, to, if you can, learn a little bit more about performing need finding studies, even if that's just interviewing 5 people who are kind of representative of who you want to help with the next thing that you're going to build. Just asking them, when was it rough for you? What has bothered you in the past? Or watching over their shoulder as they try to do something now that you'd like to make easier. It's historical inquiry and contextual inquiry if you're looking for keywords to read more about those methods. Two is that there are these existing theories of human cognition about the classes of reasoning that humans find easy, hard, impossible, with and without training, right? You know, there's things that our brains are just remarkably good at and things that we're just remarkably bad at, right? Like mentally simulating a program. So I know that existing theories of human cognition from the learning sciences, from educational psychology, from cognitive science, they're tough to leverage because they're often not originally studied in the domain of interacting with computers. And they also are often, you know, they're in fields that we may not be super literate in. There may be a lot of jargon. There's just, you know, it's a whole other field, right? So to be able to wade through the jungle and find the theories that actually have design implications for the systems that you are building, there's no even guarantee that you will find what you need. But I think it's, I've found things like, there's a theory from educational psychology called variation theory about how people, how concepts are induced in people's heads from examples, right? And that's really shaped how I think about the centrality of examples and communicating our intent to the machine and for the machine to communicate back what it's done for us, right? And that is front and center in the case study of interactive program synthesis that I showed. So, you know, finding one applicable theory can go a long way and really cut your search space down to things that are more likely to work. And then third is to develop and invest in PL customized iterative prototyping tools and techniques. So, you know, I've been talking to a lot of synthesis designers about how they prototype something that doesn't exist yet. And, you know, my initial thought was, well, Wizard of Oz, right? That's where someone pretends to be the computer, you know, like the wizard behind the screen in the classic movie. So you can make use of human intelligence to fake a new intelligent computer program. However, a lot of times synthesizers are doing things that humans would find very difficult to do, and therefore the Wizard of Oz technique doesn't make as much sense because it's difficult for the human to fake being a computer. And so, you know, knowing the value of iterative prototyping with higher and higher fidelity, right, to really test out ideas before, again, we continue to invest more and more time in them. I think that it would be really valuable to the PL community to invest in tools and techniques for prototyping. I know Michael Koblenz has recently published a paper, I think actually at this conference, on various evaluation techniques for languages that I believe could also be used for prototyping. And then to the HCI folks who are probably not here, but that's okay for any of them watching in case they're out there, I think that we should exploit the power and flexibility of programming language-backed interfaces, right? That doesn't mean programming language interface as an interface. I mean, that is an interface, and we should make that a better interface, but also we can put programming language technology behind interfaces that, you know, say, well, direct manipulation is a good example. Robbie Chug's students working on Deuce and Sketch, where because their sketching program is backed by programming language technology, they're able to have bidirectional updating between either editing the program or editing the sketch. And you know, that's a radically new and awesome way to interact with computer and get it to do what we want. And HCI folks shouldn't be scared of the technical details, or they should approach PL folks and see if we can propose mutually interesting system building projects that advance PL and advance AI, HCI. Also, we want to help people, users stay safe, right? So it's with all that power and flexibility of programming language-backed interfaces, we also have to make sure that we give users guardrails so they don't, you know, I guess back when people had C, they were able to screw themselves up way more than say with JavaScript because there were very few guardrails. And finally, that we should give users multiple ways to express their intent. I hope that case study that we talked about is a great example of how, when providing people with multiple ways of expressing their intent, yes, there's more to think about in terms of, well, which way, there's a little bit more cognitive load in choosing how to express one's intent, but at least, we see that, at least in the study that we ran, that some things are just easier to say by annotating existing example, or some things are easier to say by saying, no, never use this this particular primitive in your search for programs, say. And so rather than pigeonholing people into one, they have so many different intents that are difficult to anticipate. The more ways that we give them to express, the more likely they are to be able to express it quickly and easily. So I'll leave this screen up for the moment, or may go back to the promising directions, but I am really grateful for your watching this talk today. I hope you found it helpful, and I'm very happy to take any questions.
Thank you very much, Elena. Let's just, we can all unmute and applaud the speaker now, if people. Very much.
Can you see me as well, or shall I remove my slides?
You can leave the slides up. We can see you at the top of the screen. It's a relatively small view, but I think it's probably good to have the slides in case some of the questions refer to some of them and then you want to reshare. So just to introduce myself, I'm Mark Harmon. I'll be your session chair for this 40-minute discussion session based on Elena's talk. You can post your questions either in Clouder app or in chat. And I'm reliably informed that Chen Chung has very kindly agreed to transfer any that appear in Clouder into the Zoom chat, so we can actually use this as a ground truth, single source of truth for questions. If you want to write the question in such a way that I enunciate it for Elena to ask it, then you can put SQ for silent question. And if you would like me to call on you to ask your question yourself, then please preface it with ZQ, or just don't preface it with anything, and I may feel that I'm entitled to ask you to ask your question. So while I'm waiting for questions to appear in chat, I'd like to kick things off by asking Elena a question myself. So what I find really interesting about this work is the idea that the computer becomes one of the members of the team, essentially. There's a lot of work in the software engineering community on bots increasingly getting intelligent and commenting in diff review processes. So they move from just finding potential bugs and commenting on them to suggesting changes and fixes, which is getting more into the synthesis space you're in. And what I was curious about some of your remarks about how, the human can't really get into the mind of the computer, and that's part of the HCI aspect of your work. And I'm thinking, are there some special attributes that this new member of the team could have that might play to the strengths of the computer? I'm thinking particularly about being able to provide detailed evidence to back up the kinds of suggestions that the computer makes in a way that a human developer wouldn't, because it'd be too tiresome. So my question really is, how can we leverage the idea of the machine as being one of the members of the programming team to play to the strengths of the machine, particularly with respect to this ability to provide reliable evidence to back up claims?
Yeah, absolutely. I mean, I really like how you framed that in terms of saying, what are computers good at? Like, how can we play to their strengths? The same way that we're trying to accommodate human limitations and celebrate their strengths. I think that, so one thing I'm struggling with right now, and I don't have a good answer, but it's worth spending a lot of time prototyping to try and answer, is how do we present additional information in such a way that the cognitive load of engaging with that information is sufficiently pays off, right? So like I want the most benefit for the least cognitive effort. Programming is already an incredibly cognitively demanding process, so people don't have a whole lot left over to read a detailed message from a bot, in a sense, or they could be disinclined to be able to want to engage with it. So and yet, if the if we can find ways of presenting that information with, instead of it being a huge wall that I have to climb over, oh, now that I understand what you're trying to tell me, thank you so much. You've totally made this next part easy. Can I make that more of a curb that I can just step on? Yes, it's going to take a little additional energy, but it's been presented to me in such a way that it's trivial for me to assess, yes, okay, I want this, I'm going to keep going. So concretely, right, say I have an editor open and I'm making edits, and an intelligent agent looking at my code in the background says, like, I think you're making a repetitive change, right? This is very similar to, I believe, the blue pencil feature that's now been released in VS Code from Microsoft. Do you want to make this repetitive change, and all these other places in the document? If that's off in the side, right, now I have to kind of switch my context and try to kind of register this potential future situation against where I am. But if I can show these changes in situ, right, just by changing how I'm showing it, it's the same information, but I'm taking out the step of do this comparison piece or manage to kind of places where information is. I realize, like, not an intellectually interesting thing, but that might, a culmination of these little choices can help people take advantage of a massive amount of additional information that a computer could generate on their behalf to help them. I hope that answers your question, at least in part.
Thanks. Yeah, I'm surprised that you say that the provision of context is not intellectually interesting. That feels like a fascinating question at the junction of HCI and PL for me. Like, what is the minimum amount of context required in order to give the maximum amount of signal from this particular recommendation? That feels like a question that naturally would bring in HCI on the understanding piece, and then the kind of minimization and the would bring in the PL community. Yeah, I see you're nodding, so I guess, yeah. So another thing that developing that theme a little would be that, like, for humans in code reviews, say, if I take code review as an example, where we think of the bot now commenting in code review to suggest synthesis changes to produce new regular expressions or something like that, then what a human might do is might say a minimal thing, like a tip of the iceberg thing, and then let the other interlocutor kind of question back. And I wonder if this also feels like some very interesting HCI PL connection. There would be, how do we set up a dialogue between machine and human such that the human can ask questions of the AI, like to justify yourself, right. You're proposing this, why, and how that feels like a very interesting area that would go back to all of the earlier work on the long trend of work on HCI, where you have dialogue between machine and human. Yeah.
Yeah, I'm sorry, I didn't mean to cut you off there. I'm teaching a class right now on human AI interaction, and I have a team who's doing, this exploration of, like, what is the differential impact of having people compose questions and ask questions, right, in kind of a semi-structured language, such that the computer has any hope of understanding correctly and actually replying. And I'm of two minds on this conversation piece, because in one sense, if I show you a bunch of information, right, all at once, and you had no expectations about what was happening, it's not actually even clear what to attend to. Whereas if I explicitly ask a question, then I'm almost kind of intellectually ready for that particular answer. At the same time, it requires energy to come up with the question, right? And so I think one thing that those students are finding, and I hope they won't be embarrassed that I'm sharing their very, very, very preliminary results of their little, kind of in-class study, but one thing they're finding is that that the more expert the person they were working with, who had a mental model of what the intelligent agent was trying to do, the more the person just wanted, just show me the stuff, right? Like, show me everything. I know where to look, right? Like I have a mental model, I have expectations about what's happening already from prior experience with intelligent agents. And so show it all to me. Why are you hiding this behind? Why are you making me do all this work of asking it questions, right? Whereas people who were, say, new to, again, this was like a faked AI system. People who were new to AI and didn't have a mental model of what might be happening, how an AI system could succeed or fail on the given task. They were the ones who really seemed to benefit from being able to like, oh, well, you know, thinking about things piece by piece. I want to know about this. Here's this question. Tell me what's the answer. So I'm a little nervous about dialogue systems or conversation systems, because if the person is not good at asking questions, they may miss important information. But perhaps when all the important information is already revealed, but the human is unsatisfied, allowing them through conversation to select additional pieces from the wide additional pieces of evidence that could be marshaled to explain that's right, the right place for follow-up questions. But it's just a hypothesis.
Thanks. Just for the audience, do please ask questions. I'm going to keep on asking them until somebody else does, but feel free to post a question in the chat or on the Clouder meeting. I see Brian has a question. Your hand is raised, so I'll give the floor to Brian Hempel.
Hi, Brian.
Hey, good morning. All right, so you mentioned leveraging theories of human cognition to inform your design hypotheses, right? And so I have a couple of questions about that. One is, do you have an opinion on, say, the cognitive dimensions of notation framework for thinking about what a tool does well and not well? So for those who aren't familiar, it's the cognitive dimensions of notation are this list of, I don't know, 10, 20 different things to look for when you see a person interacting with a tool, where there's a closeness of mapping between the notation and the problem world, or where there are hard mental operations, whether you have to prematurely commit to particular choices when you're building an artifact. Is using something like that a good way to not have to read all of the literature on human cognition?
Yes, absolutely. And I would point out that the cognitive dimensions of notation, though I have not personally used them to evaluate systems, I first encountered them talking to Arvind, who's head of the, kind of a programming centric or programming backed visualization group at MIT. And now I see them popping up a lot because they can, rather than doing an explicit user study, you can kind of just go through this checklist and ask yourself, right, do these the affordances match what's recommended. And there's actually a lot of overlap between them and popular design heuristics that are applied in just user interfaces in general, right? Like the ability to undo or to preview the effect of your action, that kind of thing. And I think that these design heuristics, whatever they're called, are typically very useful and will keep you from putting something in front of someone and seeing them struggle and having an obvious fix. You're like, oh, why didn't I think of that, right? They're guardrails. But beyond that, I think that they are not a replacement for some amount of structured search of these theories about human cognition beyond that, right? So they don't tell you, for example, about what information best helps people form a more accurate mental model of the capabilities and limitations of a system.
Okay, yeah, that's always an interesting question. How do they get a mental model of what the other side is doing, right? Yeah.
So I think that cognitive dimension notation, these other design heuristics, they make sure that the immediate interface that we're working on is not it's not terrible. But I think if we're going to solve the next kind of generations of challenges of interacting with these smart systems, people are going to have to be able to make rational speech acts, right? And to make a rational speech act, you have to have a mental model, somewhat accurate mental model of the person you're speaking to, or in this case, the computer.
Okay. Then a related question is, so if I wanted to learn more about theories of human cognition, where is a good place to start? Because I don't know. I know to read TAPL if I want to learn about type theory. What do I read to learn about human cognition theories?
Oh, goodness. Let's see. So one thing that I have done, I guess, is there is some overlap in language, right? Like program synthesis by example is using often, inductive reasoning or inductive processes. And that's this, if you search cognitive science literature, I think linguistics, cognitive science, educational psychology, like those are the fields that kind of come to mind when I think of where I've been, where my searches have been fruitful, and just picking one or two keywords from like the domain that I'm interested in. And you'll find inductive learning, right, in some of those fields, and you can look at that and say, oh, like they're also using this, other word, analogical learning, right? And it sounds really similar, and you can kind of just build up this, the same way that we literature search. I've found that the cognitive scientists like Tenenbaum, right? Like he's teamed up with Armando Solar-Lozama at MIT. There's a lot of openness to collaboration from those fields. And so I found that directly reaching out to them and saying, I've already done some search, right? But here, I think analogical reasoning, can we talk more about that? Is there any other related theories to this, right? No, indicating that I'm not using them as Google, right? That they've been very helpful in either confirming, yeah, we don't know anything about that, or saying like, oh, you also forgot this theory. That might be really helpful.
Yeah, it's good. Good, thank you. I don't see any more questions, so I'll just keep asking if it's all right.
Go ahead.
So
absolutely fine. Keep the floor, Brian. But if anyone else has any questions, do raise your hand, and I'll interject. Thanks.
All right. So this is taking a little different direction. You mentioned a lot about doing these exploratory studies to see what problems people are actually having, and it's certainly true. I think that a lot of really good tools come out of actually watching what people do. And trying to learn from experience. So I think at the live programming workshop on Tuesday, talks about, Mary Beth Carey talks about how IPython notebooks were born out of years and years of looking at what other people were doing wrong with notebooks, and building a design that was going to work for them in the work that they needed to do. And then of course now it's taken over scientific computing. I wonder though, if you look at what people are doing, if you are also closing yourself off to more radical ideas and more radical changes, right? So Henry Ford's famous quote, if I'd asked people what they wanted, they would have said a faster horse, right? So yes. I also realize that I make this complaint because I'm a little bit lazy and don't want to do the exploratory studies and just want to build the crazy thing that's in my head. So I don't know if you've had further thoughts on this tension between iterative improvement that comes from looking at what people are actually doing versus the insight that actually is going to be transformative that people might not understand immediately.
Yeah. So if you had not read that quote, I would have mentioned it, right? And it shows up a lot, right? Even in kind of, they may be apocryphal stories. You don't have to go to the automobile days. You can look at the early days of computer interfaces where they, the guy goes down to the basement where the secretaries are typing things up on their typewriters and being like, if you could have like a word, if you could have a typewriter but electronic, what would you want it to do? And they're like, automatic carriage return, So I think that I think it's wrong. I'm not saying, I think it's wrong to use that quote as an excuse not to watch, to interact with people. Though it is effortful. Though I will note that it's not that effortful. If you want to do like a formative study that you write up in your paper, it's effortful, right? Mm-hmm. But if you want to just get like, ask your roommate, hey, can I watch you, try to use this function in Excel, right? That's kind of funky, right? Like it takes like 15 minutes, an hour max if you're, asking them to or talking to them about something complex, right? It's like the cheapest thing. And the trick here to not give people faster horses, right, is to people are in certain ways unreliable narrators. And so, you know, looking behind the story, right? They say they want to do this, but they're behaving in a, like, you know, they're, you know, challenge yourself to see beyond what they're telling you they want and look at the behavior. And if there's a, and, you know, feel a little bit like a Holmes, you know, take what they're saying with a grain of salt. And also, I mean, I think it's, again, when I talked about those, you know, kind of, well, these different rounds, right? You can start with your approach. You can say, I woke up from this dream and I had this like amazing thing and it's so cool and everyone's going to want it, right? You know, like, and I think that the challenge is just to believe in that idea, right? Modulo some tweaks, right? Be open to tweaking it as you kind of just, you know, as you're developing it more and more, to also get a sense of, you know, exactly what need does this fill, right? Maybe you don't even change your approach. You woke up from a dream, you're like, this is the most radical, cool idea for interacting with computers, right? And if you don't want to update that, then just be really specific about the particular need that addresses. Also, you know, I would say that, you know, there's especially in HCI, there's this push towards simpler interfaces, right? Like if it's not immediately usable, it's unusable. It's like, no, right? You know, Excel takes a while to learn, right? You know, it just if someone pushes back and says, oh, this is unusable, right? Your new radical way of interacting with computers, say, look, it might have a, you know, it's got it doesn't have a low floor, but it has a high ceiling, right? Make sure that the effort that someone has to put in to make use of it, to learn how to use it really well, is worth it. If it's, and that's hard to measure, right? In a certain sense, right? But if a 1 hour user study is not appropriate for your system because someone's going to need to use it for a week to really get competent, don't do a 1 hour user study.
Right. Like hire one person and have them use it for a couple of weeks or something. Right. Yeah. Yeah, because, you know, you open up any sort of professional creativity application and there's 100 buttons and triply nested submenus. There's a reason those things are there.
Right. To go, yeah, no, everything cannot be super simple. I think for me, it's about figuring out, making sure that nothing is more complicated than it needs to be. Yeah. Right. If that complication is necessary, you know, just make sure there's no additional complication. It's already hard enough.
Okay, thank you. Yeah, I don't know if I have any more questions at the moment.
I really appreciate it. I'm so glad you were able to make it. I hope you appreciate the call out to Deuce.
Yes. Yeah. Yeah, and you mentioned that, you know, sometimes you mentioned to the PL folks or the HCI folks to not be afraid of advanced techniques. And I think that, yeah, it's one of those things where I could reach out to cognitive scientists. Well, you know, someone could reach out to me and say, here, how do we do bidirectional updates? And I'm like, well, there's a bunch of different ways you can do it, and not all of them are that hard. So here you go. Right.
There you go. Thanks, Brian.
Yeah.
Thanks, Brian. So there aren't any questions on Clouder just at this point, but if any of the other people in the audience have questions, please either raise your hand or just put something in the chat and I'll read them out. In the meantime, I have another question, if I may, Elena. So just for a bit of context, my background is one of the areas I've worked in is this area known as genetic improvement, which is kind of related to program synthesis. I don't know if you've come across I can give you some more context if not, but
genetic algorithms?
No, well, genetic improvement uses genetic algorithms to improve code. The difference with synthesis is that in genetic improvement, like genetic programming, your correctness criterion is passing all the tests. So if you had only one test, you could delete all the code except the code needed to pass that test. So it's very aggressive in terms of what you can synthesize or what you can do, or you could say it's very weak in terms of what your correctness criterion is for whether the synthesis is correct. But there was some work there that showed that you could automatically discover and generate new features for existing systems relatively easy from a kind of a cookbook of existing fragments of code. Essentially, it was kind of brewing them together and then composing them. But there was an interesting interplay in that how much the developer needed to say in order for the genetic improvement algorithm to work. So if the developer would point the algorithm to APIs and give examples, the examples could be completely wrong, but so long as the examples use the right APIs, then the genetic improvement system could mix and match until it found the right thing. So this felt to me like it was a really interesting example of where the machine has this ability to do lots and lots of tedious legwork, and the human has this kind of unique insight that, you know, if you just point me to the right kind of starting place, you can give me all sorts of wrong things in the right area, but then the machine can turn wrong into right, as it were. But if the machine's not even in the right kind of problem domain or in the right, you know, then the human could do that really trivially. So most developers really, like, if I'm faced with a problem that involves, I don't know, string matching and regular expressions, I know exactly which Python libraries would be relevant. So expecting an algorithm to find that automatically seems silly, right? I could say I could do that trivially, but then working, and I also probably know some example fragments that I could throw into a sort of just a pot. But the tedious bit is like, you know, as a programmer, what often spends time is like, oh, I should call that before that, and then this has this dependency, and I have to inject that into here. But all that can be kind of discovered by trial and error. In fact, sometimes as programmers, that's exactly how we do discover it. And I wanted so it's a very long, rambling kind of question, but what I'm leading up to is asking whether you had any thoughts on, from your work, on how this sort of balance between the human giving that little 1% inspiration and the machine doing the 99% perspiration would play out in this synthesis work.
I love that. I love that reimagining, or new domain for that particular idiom. Yeah, no, absolutely. I am thinking actually of an unpublished study in submission, but I'll say that what we found, well, Tini called it the last mile problem. So the idea that, you know, the human coming to a challenge didn't have a good idea of what of kind of like where they were going. They actually didn't know exactly where to start. Okay, and then the system starts, you know, exhaustively, you know, doing all the perspiration, like, oh, well, how about this, how about that, and as the human is interacting with this perspiring system it's trying its hardest, right, but is also spending inordinate amounts of time in various, you know, dead ends. At some point, as the human is like, oh, that's a dead end, you know, ignore that, or, oh, you know, yes, you definitely want to be using this function. You know, please continue your search, always at least including that function somewhere in what you're composing. At some point, people might realize, like, have an aha moment of, you know, even though the system, it's almost like the reverse of what you're describing, where the system is like trying lots of things, right, and it's still wrong, but it's the human who says, oh, you know, it's this, then that, then this, that's it, right? And they have that aha moment because the system helped kind of helped them understand the space and what was possible a little bit better. And at that point, it actually doesn't really matter if the synthesizer finishes. Like the person in interacting with the synthesizer that was trying everything it could, right, gets to the right answer and it's like, yeah, I could write that down, right? And yet in the study, we were like, can you get the synthesizer there, right? And it's like, well, it doesn't actually matter if the synthesizer gets there eventually, right? Through interacting with the system, an answer was come to. It doesn't really matter which entity of these two in communication came up with it first.
Thanks.
Like a rubber duck debugging.
Yes.
Sorry, Brian.
Yeah, go ahead, Mark.
Sorry, I spoke over Brian. So do you want to say that again, Brian, in case we all missed it?
Oh, yes, like rubber duck debugging, when you know, put the rubber duck on your computer and top of your monitor and just talk to it.
All right, yeah. Thanks. I see there's a question, so I'm going to go to that one in a minute, but I just wanted to follow up on your comments there, Elena. So this idea of like the eureka moment, and I've often thought about that, like the machine produces this stuff and it can be a bit wrong, but then that gives the human the eureka moment. That's often another theme of the genetic improvement work, is like, well, maybe if it can produce a nearly right solution, then the human can do the last mile, as you talked about. But I was kind of interested in putting it the other way around. So the work I was referring to earlier is called Babel Pigeon, because it was developing a new language translation feature for the Pigeon system, and it was kind of like a Tower of Babel. But anyway, that's by the point. But in that work, what happened was it's that the human does the aha moment before for the machine. So it's almost like the aha moment is for the machine rather than. And the interesting thing about that is, you spoke earlier about humans being, the amount of effort involved in processing all this spew that comes out of the machine, and that being kind of hard for the humans, and that's a kind of real blocker to deployment and impact for this research agenda. But if we put it the other way around, if the human first of all just knows like a few things they have to say to push the machine on the right track, and then the machine does all the rest, that feels kind of like more likely to be a successful route to impact. And that was what's I thought was interesting about this way, just pointing to the right APIs and a few fragments of code, and off it goes and it comes back. So now as a human, all I have to do is say, is the answer right? And I've got all these test cases passing, so I'm kind of happy, rather than having to read all this spew from the machine. Anyway, it's not really a question. It was just a kind of follow up on your.
Yes, well, I think that I think that a truly usable future system, like AI or sorry, doesn't matter if we call it AI, program synthesis, whatever, right? Of intelligent augmented code experience is going to have to incorporate both. I have no idea. Help put me somewhere, right? And maybe I'll get an epiphany later, right? Because you helped me explore the space. Or to say, I have a general idea of where I need to be, and the computer is like, aha, this is what, thank you for putting me in the right region. Here's the answer. I think both will be components of any successful, commercially available deployed system.
Thanks, Elena. Yes, thanks for that. So, Chin Chung Su has posted a question from Joel Jakubowicz. I apologize to Joel if I've mispronounced your surname. So this is a question for me to read out to you, Elena, but you can probably read it as well. But just in case there's anyone who's just on audio, the question is as follows: on being a bit of a detective (brackets Sherlock Holmes), so the user might be saying they want faster horses, alluding to the Henry Ford example that Brian spoke of earlier. As a detective with an idea for engines, I interpret this as them wanting to go faster, with no particular loyalty to the horse part. And maybe I should ask them if they would like to go faster on something that's not a horse. Is that what you were getting at?
Yeah. I like that phrasing, in that, the horse is an approach to the need to go faster, right? And it's the approach that they're aware of, right? But you, as someone who can generate new approaches, right, should not get hooked on the characteristics of the approach that they're asking for, but rather say, what are the obstacles, too slow or whatever, or goals, go faster, that are implied by the solution, that the thing they're asking for. Yeah. So that's a nice example with the horse.
To take it a step further and following on the theme with Henry Ford, Ford might also have thought, well, they're asking for a faster horse, but actually oftentimes when they're riding the horse, they get extremely wet if it's raining, but I'm going to give them something which won't only go faster, but will actually also keep them dry. Now, this is different because this is not just extrapolating that the requirements have unnecessarily bound up the solution into the requirements, which is something we often do in software engineering. We propose the solution rather than the problem, and disentangling the two is important. So, okay, so we've now disentangled that speed is the issue, not horse. But actually Ford, I think, had some other insight there, because he's giving the user something they didn't even know they required. That to me was the deep insight. And I wonder, for me, that feels like I don't see how AI is ever going to tackle that challenge, but maybe I've got maybe you can stand me corrected on that one.
Yeah, I mean, I think, as humans, we're able to, we still are really good at, well, I don't know. Okay, I don't know if I want to compliment us on dealing with unknown unknowns, but certainly that is a real problem for AI, right? Like if you give AI a problem and the representation of the problem or the data, right, does not include some feature, right? You know, the AI system will never be able to get around that. So that's why I think human in the loop situations will be how, you know, yeah, AI, it's by itself may never get there, but humans are how do we design effective human AI interaction, collaboration, communication, such that, like you said earlier, the strengths of the computer are on full display and fully leveraged, and its limitations are that the interface with the human, the amount of information and the way that that information is presented to the human allows the human to kind of fully cooperate, not be overwhelmed, and have as much, well, in my eyes, all the agency, right? I'd rather see the human have the upper hand in that relationship to a certain extent. I'm not ready to submit to our robotic overlords. So I'm focusing, you know, on like AI augmentation with that kind of approach of rather than the human kind of acting to serve as the blind spot detector for the AI. But everyone has their own research taste about what aspects of this problem they'll try to solve.
Thanks.